Hello, this is in continuation of our our lectures on photochemistry. We have been discussing for last 2-3 lectures the type 1 photoreaction in aliphatic carbonyl compounds. We have looked into a variety of examples for for type 1 reaction in alicyclic ketones, and also people have tried by taking different substituent in the at alpha position in alicyclic ketone to see the type of product form, and we have already seen that the in the cyclic ketones, alicyclic ketones, the aliphatic cyclic ketones, if alpha position is substituted by a cyclopropane ring, there is a possibility of the preferential ring cleavage to give a more stable secondary radical, and also this radical is stabilized by the presence of a cyclopropyl group, which is considered equivalent to a double bond, and hence any radical adjacent to cyclopropane or a double bond is stabilized, and hence since there is a radical adjacent to the cyclopropyl group, it opens up to give a carbon center radical, and then which once again couple with the acyl radical to give a ring expansion product. So two carbons of the part of the cyclopropyl group becomes the part of the cyclic ring. We have also seen another example where the two cyclopropane rings are substituted on alpha position, one cyclopropane connected to another cyclopropane, and then we have also seen both the cyclopropyl group, I mean 6 carbons becomes the part of the ring, and then we end up with a from the 6-membered cyclic ketone to we end up with a 12-membered cyclic ketone. So it is extremely interesting example to synthesize macro cyclic ring system. Now coming to the next series of reactions which is observed in the case of carbonyl compound is the type 2 reaction, which involves gamma hydrogen abstraction by the excited carbonyl. So in this one, when we have a carbonyl and we have a CH2, CH2, CH2. So this is 0, this is alpha, this is beta, this is gamma. So if we have a carbon, gamma hydrogen is available, then in the presence of light, the carbonyl goes to an excited state, and this excited state can abstract the gamma hydrogen to generate 1,4 radical. So this is the abstraction: alpha, beta, gamma, CH2 radical, and then the alpha, beta, and gamma, and then 1, 2, 3, 4. 1,4 radical is formed, and then this combines to give the cyclobutanol as one of the products. So you can see is one of the most important reaction in the case of carbonyl compound is the type 2 reaction, where whenever there is availability of gamma hydrogen, the excited carbonyl abstract this, generates 1,4 diradical, and this diradical once again couples to give cyclobutanol. So construction of a ring is, as I have mentioned earlier, the construction of the constrained ring system like cyclopropane ring, cyclobutane ring has attracted a lot of attention, because this ring, smaller rings have contained lot of ring stain, and hence it is not easily formed. So in this run, the cyclobutanol as one of the product. Of course, there are some side reactions also. So let us see this reaction in more detail. So this is an example where you have a carbonyl compound. This is a carbonyl compound. There is a phenyl group attached to the carbonyl, and other part of the carbonyl connected to CH2, is alpha carbon, CH2, beta carbon, and then alpha carbon, alpha, beta, and then gamma. And then this gamma has R1 and R2. So whether if R1 and R2 being H, means this is equal to CH3, or R1 is equal to CH3 and R2 is equal to H, means one of this is H and then the other one is CH3, and then or both R1 and R2 is CH3. But still in all these three cases there is an availability of this gamma hydrogen, and since all these three compounds undergo type 2 reaction, that is gamma hydrogen abstraction by intramolecular gamma hydrogen abstraction by excited carbonyl. So when we shine light, it undergoes type 2 reaction, that is gamma hydrogen abstraction to give an excited carbonyl. This excited carbonyl abstracts this gamma hydrogen to generate 1,4 diradical, and then it gets the cyclobutanol as one of the product in this type 2 reaction. It is not only the product, but this radical also undergoes decomposition or fragments. So this radical goes like this, and then this goes like this. So there is a second product where the exclusion of alkene is a second product. There is this part is gone goes as a alkene moiety, and then this is a enol form. This is in form from tautomerized to more stable keto form. So this is the third product. So essentially type 2 reaction in aliphatic carbonyl compounds, whenever there is a availability of gamma hydrogen, the excited carbon in the presence of light undergo type 2 reaction. Excited carbon abstract gamma hydrogen to generate 1,4 diradical. 1,4 diradical undergoes two different pathways. Number A pathway is to coupling of this 1,4 diradical to give a cyclobutanol as one of the very important product, because it generates a smaller ring system, and we have already seen that the generation of a smaller ring system is not very easy because of the high ring strain, and also the construction. This not very many ways to construct cyclobutane ring by any other chemical treatment method. The second route B is opened by this 1,4 diradical decomposes or undergo fragmentation to give this cleavage of this bond. Beta bond takes place. This is alpha, this is beta. Beta cleavage takes place to give the removal of alkene moiety R1 and R2, and then third one is enol form with tautomerized more stable. So out of these three products, one of the product is most important, but the disadvantage in this reaction is that this product, the cyclobutanol, which is synthetically important, it is formed in a very low yield, around 6%. When in the solution photochemistry, when we do the photolysis of this aliphatic ketone and all this 1 to 3 in the presence of light, and in any common solvent like benzene, toluene, cyclohexane, or acetonitrile, any of these. So under any common solution phase photochemistry, these three products are formed out of this. The the cyclobutanol is formed in very low yield, and then which is the most important product in this reaction. So people have tried different ways to increase this synthetically most important cyclobutanol product in the type 2 reaction. And for this, before coming to the to increase the product, I will next few transparency I will see few few examples of type 2 reaction. I have just collected few examples of type 2 reaction. In all these cases, this is a second example. This is the first example where R1 R2 is R2 R3 is kind of different. Second example is a third example of type 2 reaction, and this is the fourth example of type 2 reaction. All these starting compounds contain alpha hydrogen, gamma hydrogen. This is alpha, this is beta, this is gamma hydrogen. So of course this is a nitrogen, and SO2 is a, and this carboxylic acid is the part of the some of the important drug moiety. So but our aim is to look at the photoreaction of this, and we have what we have learned in the previous slide, that whenever there is a availability of gamma hydrogen with respect to the carbonyl compound, with respect to carbon compound, in the presence of light, the carbonyl gets excited, goes to an excited singlet and then excited triplet state, and then excited state can abstract a gamma hydrogen, the gamma hydrogen abstraction by gamma hydrogen abstraction by excited carbonyl takes place to give 1,4 diradical. 1, 2, 3, 4. 1,4 diradical is formed, and then this can this is nicely set for 1,4 radical coupling to give this 4-membered ring, and of course this is 5-membered ring initially. So you can see here we have constructed a 4-membered ring where nitrogen is the part of the ring system. So this is also these compounds have a lot of synthetically important, and people have tried to look the how to construct 4-membered ring by taking a suitable starting material. So this is another example of type 2 reaction where the excited carbon abstract gamma hydrogen from the 5-membered ring, which is between the nitrogen and sulfur, and then generation of a 1,4 diradical, and then a coupling of this 1,4 diradical. The third example here, and again if you look at this molecule here, we have again set for this is alpha carbon, this is beta, this is gamma. So there is an availability of gamma hydrogen. So in the presence of light, this will also undergo, carbon gets excited, goes to an excited state, and excited carbon abstract gamma hydrogen abstraction in the presence of light to give a 1,4 diradical. 1, 2, 3, 4, 1,4 diradical, and again this is since there is a cyclopropyl group and there is oxygen, of course if you combine this diradical, it looks like this. Since this product on paper it is okay, it is fine because this diradical can, but again this has a lot of under ring stain. There is first of all there is a 4-membered ring, there is a presence of oxygen, there is a cyclopropyl group as a substituent as well, and since there is a radical adjacent to a heteroatom, this has more susceptible to undergo the ring opening or cleavage, beta cleavage. This is beta bond. This forms a C double bond or cyclopropanone as one of the product, and then of course this is the enol form, and then this will tautomerize to give a keto form. So but the main reaction is the type 2 reaction. Type 2 reaction in the presence of light where the excited carbon abstract gamma hydrogen to give a 1,4 diradical. This 1,4 diradical is open for coupling, radical coupling or fragmentation. The fragmentation has been reported is more susceptible because there is a carbonyl adjacent to the cyclopropane ring, which might open more very fast to give a cyclopropanol, and then fragmentation product is the as one of the product. Of course, if we can combine this, we get this, but I don't know whether experimentally this is form or not, because it has not been reported in the literature. These examples are all reported in a standard photochemistry book taken from N.J. Turo. Now this is another example, is a steroidal system, and we can see here is the carbonyl, and there is a CH3 here. The position of this CH3 with respect to carbon is again alpha, beta and gamma. So this is in the presence of light is also again set for gamma hydrogen. Of course, there is a methyl group here as well, alpha, beta, gamma. This is also a gamma position, but the orientation of the carbonyl is such that it can abstract a gamma hydrogen from this methyl group, and hence this is in the presence of light, the carbonyl goes to excited state. Excited carbon abstract gamma hydrogen from this methyl group to give a CH2 radical. And then this 1, 2, 3, 4. 1,4 diradical. 1,4 diradical is formed by gamma hydrogen abstraction by excited carbonyl. By excited carbonyl. By excited carbon to give 1,4 diradical, and then this can combine, this couples to give a 4-membered ring. This is again very important product, because the construction of a 4-membered ring in a steroidal system is not very easy, but through this photochemical route the carbonyl can abstract the gamma hydrogen from this the presence of a ring junction methyl group to give a 1,4 diradical, and then to give this. This is a reported product. I do not know the yield of this product, but it does reaction does takes place, and it follows type 2 reaction by abstraction of the gamma hydrogen by excited carbonyl to give a 1,4 diradical, which couples to give the this is the only pathway open here, because this 1,4 diradical cannot fragment in if it fragments, so it has to cleave the if it opens like this, it has to cleave this, which is not very favorable, because the is a steroidal system, cleavage of the ring is not very, so the only product open for is the coupling of diradical to give rise to this steroidal system. Now, as I have so these are few examples of type 2 reaction where the carbon abstract gamma hydrogen to give the 1,4 diradical, which combines to give a cyclobutanol as one of the product, and the enol, which tautomerize to ketone. But in some cases, when there is a molecule 1,4 diradical is adjacent to a oxygen, as it opens up, and the cyclobutanol is not preferred. As I have mentioned that in all these cases, the product which is formed is the cyclobutanol ring is very important, as because other product is just a fragmentation product, acetophenone, and but this product is formed but the formation of this product is very low, is just only 6%. So people have people have tried, say for example, C double bond O, alpha, beta, gamma. This is a carbonyl, alpha, beta, gamma, and then excited carbonyl CH2H, abstract this. So we get the 3 products. H, this is H nu in the presence of suitable solvent. In the presence of suitable solvent, we get this. Plus, we also get the, so for example, this is pH. So we get pH CH3. So in a normal in the solvent is the percentage of this product which is more important is only 6%. So people have made a lot of attempt to bring about selectivity in photoreaction. Selectivity in the sense that how we can increase this yield of most wanted product. So maybe if an increase by 6 to 20 to 30% or even more is going to be very a good and achievable target or the aim or objective. So here so the objective is to how to increase this product from 6% to the 20 to 30% yield, and if we can somehow, if we can increase this 4-membered ring to 30%, this reaction is going to be a really an important reaction for any synthetic route. So so this is the reaction we mentioned 6%. We want to increase this. So people have tried to bring about selectivity by carrying out the reaction in organized media such as cyclodextrin, micelles, zeolites, and liquid crystals. These I mean the medium are considered as the organized medium because the molecules are set. So for example, cyclodextrin, we know that is a cavity-like structure, is a oligosaccharides of 6, 7, 8, 5, 6, 7 glucose unit in a cyclic manner to give a cavity-like structure. Micelles are of course hydrophobic and hydrophilic end, and it forms a globular type structure. Zeolites again is a channel-like structure. Liquid crystals again is a cholesteric and pneumatic and different types, and then they are well organized reactions. So these are the organized media. People have tried to increase the most wanted cyclobutanol product in this organized media so that they can increase the product, the wanted product in this. So I'm just going to take up only one medium, that is cyclodextrin, just to see that how cyclodextrin brings about selectivity in photochemical reaction. So you just stop here and then continue on the next turn. So how to see that how cyclodextrin brings about selectivity in photochemical reaction to increase the most wanted cyclobutanol product to so that this reaction could be of any synthetically important product. So in the next lecture we are going to discuss very briefly the structure of cyclodextrin, and then how cyclodextrin are used to form host gas complexes, and once the host gas complexes form, they can be, when we do the irradiation, is bringing about selectivity in the reaction to give one of the product in the major form, and how the selectivity is achieved is going to, we will discuss in the next turn. Thank you very much.